Welcome to aminacademy.com. In physics formulae and their explanation, let us discuss about force. Force. The formula for the force states that the force is equal to mass that is multiplied by the acceleration. So, if we know the mass of the acceleration, mass and the acceleration, we just have to multiply them together and then we will get the force. So, force is F equal ma, mass into acceleration. The force is basically an interaction between the objects because of which they make changes in their motion. That means the force is measured in newtons. That means the force is the interaction between the objects because of which they make changes in their motion. Next, Newton's laws. Newton's first law of motion. The first law of motion by Newton says that every object persists to be in uniform motion in a straight line or in the state of rest unless an external force acting on it. That means it's always be in rest or in uniform motion unless otherwise some external force is disturbed on it. Second one, the Newton's second law. The second law of motion by a Newton says that the force is equal to the change in momentum per change in the time. For constant mass, force equals the mass times the acceleration. F equal to ma, we know that. A vector quantity, that is a vector equation, is the modern statement of Newton's second law. That is F vector equal dp by dt, change in momentum with respect to time. Then where P vector is momentum vector, that is P equal to mv, and the time interval for the applied force increases. As a result, the value of the force applied decreases. The time interval increase, the value of force applied is decreased. From the Newton's second law, force vector is directly proportional to dp by dt, then which is equal to force vector equal to k into dp by dt, which is dp by dt is an acceleration. Therefore, k here m mass into acceleration is equal to force. Therefore, F vector is ma. Newton's third law. Every time a body exerts a force on another body, the latter is simultaneously exert an equal and opposite force on the first one. In vector form, F12 is the force of the body from one on the body 2, then and F21 that of the body 2 on a body 1. Therefore, we can say F12, force 1 to 2 is equal and opposite, that is minus F21. Therefore, in system we can say F12 plus F21 is 0. Then effect of resultant forces. First, what is resultant forces? The resultant force, also known as the net force. Net force can have several effects on an object motion. First, balanced forces. If the resultant force is 0, the force acting on the object are balanced and cancel each other out. The object will remain stationary or continue moving at a constant speed in a straight line. Next one, accelerated motion. If the resultant force is not 0, the object will accelerate in the direction of the force. The greater the mass of the object, the more the acceleration is impended. Therefore, next one, deaccelerated forces. If the resultant force acts in the opposite direction of the object motion, it will deaccelerate or retard. That is, slow down the object motion. Now, next one, we'll talk about unit of force. Unit. Newton, dyne. Newton is kg meter per second square. Dyne is gram centimeter per second square. Therefore, you can say 1 Newton equal 10 to the power of 5 dyne. Here, look at here. What is normal reaction? Normal reaction is the force exerted by a surface to support the weight of an object resting on it. Here, look at here. Suppose a ground, horizontal ground, on that a block is here. Block is resting on a horizontal. So mass is m and it acts down at mass into gravity, that is W. Here, all this, we can say its normal reaction is upward. Therefore, we can say N equal to mg. Next one, tensile force. Yeah, tensile forces, also known as the tensile forces, are forces that stretch or elongate a material. They can cause object to deform, accelerate, or undergo other changes. Here, for example, from the ceiling, a block is hanged. Mass m. So this downward force is mg. Then here, this is tension in the rope. Therefore, you can say tensile force is equal to mg. Next one, application of Newton's law. Look at here. Here, the first law is like, that is applying a force, it moves. Second law, here, by applying a force, the body is accelerated, F equal to ma. Third law, every force there is equal and opposite forces. Now, first in application of Newton's law, first one is motion of a black block on a horizontal smooth surface. Suppose this is a horizontal smooth surface. On that a body of mass m is resting. This mass m, this a pulling force is applied here. It is normal reaction. This is mg. So here F equal to ma, or acceleration due to the force, pulling force F over m. Now here, in case 2, look at here. Suppose the some body is resting on a smooth surface. That's here mg is weight. Here normal reaction. Suppose the force is not applied horizontally, the force is applied with some inclined direction. That is a theta. Here this, when that it is vertical component of this force is F sine theta. Then horizontal component is F cos theta. Here mg equal to R and force is applied if have the component with horizontal F cos theta with vertical F sine theta. Next one, motion of a body in contact. Suppose, look at here, some surfaces, horizontal surface, in that two bodies resting on contact between them. Force here, F is applied like pushing this block A, this block B, then mass M1 and mass M2. Between them is force is like a force is contact force. Now this, look at here, for this A is acceleration of the body in the direction of the force application, that is F over both masses added M1 plus M2, and F is, and force F is M2 total F over M1 plus M2. Or here M1F over M1 plus M2 also I can do for force by this body to this body, this body to this body. Then if the system is large, that is three systems here, look at here, in that three bodies. First, second, and three bodies are in contact. Now look at here, this mass is M1, M2 and M3. In that manner, these bodies are named A, B, C. Force applied here. For this, acceleration A can be written as force over the masses added M1 plus M2 plus M3. Next, motion of your body on a smooth inclined plane. Here, smooth inclined plane, look at here. A body is right here. This is a normal reaction. Here, this is mg, angle between is theta. Here, acceleration, the force is mg sine theta mg cos theta. This is a motion of a body on smooth inclined plane. Next one, pulley block system. A pulley system makes use of disc-shaped block that a rope wraps around and create a simple machine. The tension force that is applied on one side of the rope uses the pulley system to divert the force in different directions. So, if single pulley system, rope is wound around, here two bodies with first body is M1 and gravity, second body is M2G. Therefore, here the tension in the rope. There, here we can say T1, tension 1. T1 is M1G and T2 equal to M2G. Like the pulley, this is a single pulley system. In most cases, the pulley is combined pulley system, and that is we can use as a simple machine. That means what? It's the work should be easily done by using pulley system for lifting the heavy body by using little forces. Next one, climbing on the rope. Climbing on the rope, T is greater than mg here, the support tension here. If T is greater than mg, mg means mass and gravity, accelerate upward, equal mg, body accelerate upward. Similarly, T is lesser than mg, the body accelerate downward. Next is spring force. The spring force is the force that a spring exerts when it is stretched or compressed, displacing it from its equilibrium position. It is also known as a Hooke's law of force. The equation of the spring force is F equal to minus Kx, where K is the spring constant and X is the extension. Here the spring force system is like yes, spring body mass M is then it's pulled and released, so it's oscillates. If force is applied by pulling and released the force, so it's what oscillate. Next one, what is pseudo force? A pseudo force, also called a fictitious force or an inertial force, is an apparent force that acts on all bodies whose motion is described using a non-inertial frame of reference, such as a rotating reference frame. A pseudo force arises when a frame of reference is accelerating compared to a non-accelerating frame. Look at here, suppose a vehicle having a body lying on that. Suppose the vehicle speed up in this direction. What happened? This body try to move backward. Suppose you're moving forward, that slowing down. While the vehicle speed is slowing down, this body tries to move forward. So it's a pseudo force. This also happen in lift mechanism, going up and down. So we feel the pseudo force. So far we discussed about various types of forces and how it acts in the body, how its reaction happen, and different types of formulas they had done. Please subscribe our YouTube channel.